we're going to start looking at simplifying radicals just a little bit in this section. We're going to have a more in-depth video down the road, but right now we're focusing on simplifying radicals partly because of the quadratic formula, and we're going to be working with the quadratic formula and needing to simplify them along the way. We are not going to take the square root of 32 and punch it into our calculator and get a decimal approximation. Pretty much everything we do in here is exact unless we're dealing with some story problems, dealing with real-world applications, or graphing pieces. So if we have to give an answer, it has to be an exact answer. So we have to go through how do we simplify radicals. There are a lot of different ways to go about simplifying your radicals. I'm going to show you a couple of them. Pick which method you prefer to use. One of the ways that I start to look at it is what perfect squares can you work with in 32? The goal of a square root is to find what perfect squares are in there, because when I take the square root of a perfect square, I just get that number. So if you think through, okay, 32, what evenly goes in there? 2 does. 2 is not a perfect square. 4 does. 4 is a perfect square. So look for a perfect square. Now some of you are going, wait a minute, there's a different perfect square that works. You're right, there is. But I'm going to start with the square root of 4 times, well, 4 times what is 32? 8. Exact same statement above and below, just written a little bit differently. So that's the same thing as the square root of 4 times the square root of 8. Multiplication can be separated. And you all know the square root of 4 is 2. And then I have the square root of 8. Problem is, now I have to look at what's underneath that radical. That number has a perfect square still in it. There is a perfect square that goes into 8, which is 4. And what's left? 2. I write it out this way because some people have a hard time, okay, when do I take the square root of it? When don't I? If you just go through the methodical process, you'll be just fine. 2 times the square root of 4 times the square root of 2. So it's 2 times the square root of 2, which is 4 square roots of 2. So the square root of 32 is just 4 square roots of 2. Now, if I would have found the largest perfect square initially, that would have made this process easier. And some of you probably even thought about it because it's pretty easy to see 32 is divisible by 2 and 16. So 32, square root of 32 is the same thing as the square root of 16 times 2, which is the same thing as the square root of 16 times the square root of 2, which is 4 square roots of 2. Done. Done. Different process, a little bit more time, the first one because I didn't get the largest perfect square, but either way I get the exact same process. Now, part of the reason this also works is you can think of this in tree diagram form. If you remember tree diagrams, what goes into 32? 2 and 16. 2 is a perfect square, so that's done. 2 and 8, you don't have to do 2s. You can do however you want. 2 and 4, 2 and 2. So like for instance 16, I could have split up into 4 and 4 and broke those down. I just happen to do all of my prime numbers. So now I have 2's here. So now what I look at is these are perfect squares. Squares mean 2 of them. 2 of them. That one doesn't have a pair. So this here is 4. Well, 4 has to be a perfect square. This here is 4. That has to be a perfect square. This is the leftover piece. Whatever doesn't have a partner is what goes under there. So if there was a 2 and a 3 left over, it would be a 6 that would be underneath there. And then this, when I take the square root of it, is 2. And this, when I take the square root of it, is 2. So that's all multiplication still. So that's 2 times 2, which is 4 square roots of 2. Another process you can use, just another option. Whatever you feel comfortable doing is completely fine. But the point of this is you have to be able to break down basic radicals, because then we're going to get to problems like this. When you do the quadratic formula, you're left over with something that looks like this problem. Before you can even simplify anything down, you need to break down your radical. You have to break your radical down first. So I need to break down the square root of 40. Square root of 40, perfect square it has in there is 4. What's left over? 10. So it's 2 square roots of 10. So I just skip that in between step of square root of 4 times 10. So instead of square root of 40, it's 2 square roots of 10 over 4. Now, I will have people at some point in time start happy slashing. You cannot cancel over addition or subtraction. Ever. 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 The only way you can cancel is when they are factors. Multipliers. So what I have to do is I have to factor out something across the top so it cancels with the bottom. Kind of look ahead as well as you do this. So I have to see, okay, I have a 4 in the bottom, and I have a 2 here, and I have a 2 here. I can't go under my radical to pull anything out. What's under a radical stays under a radical unless you can break it down with a perfect, in this case, square. So I factor out that common factor of 2. Okay, so 2 times what gives you 2? 1. You got to have a 1 there. Plus or minus this 2 times what gives me 2 square roots of 10? Just the square root of 10. So I took care of my numerator. My denominator is 4. Because I have factors now, I can cancel. 2 goes into 2 once, 2 goes into 4 twice. My final answer, therefore, is 1 plus and minus the square root of 10 over 2. You may be tempted to try to cancel that square root of 10. You cannot. It is underneath that radical. It is a square root. I can't all of a sudden just start canceling underneath it. I'd have to be able to break that down right away, which is why I tell you from the very beginning, break down that radical, and then you'll be able to work through the process. And this is my solution. If I were doing the quadratic formula, I'm solving for x, this is what I get. In this case, I'm just simplifying. Here's another one. Take a moment, please. Try to start breaking this down. First, break down your radical. Then see what you could possibly factor out and keep going from there. So I broke the radical down. I rewrote it into my problem. Now I have to factor out what I can. I have a 3 in the bottom, so look across the top. Can I factor out a 3 of some sort to cancel it? Yep. I can factor out a 3. So 3 times 2 gives me 6. Plus and minus 3 times the square root of 2 gives me 3 square roots of 2. All over 3. Cancel those 3's. So my final answer is 2 plus and minus the square root of 2. That is my simplified answer to this problem. Break down your radical. Factor out your what's common. Trying to get it to cancel with the bottom. Sometimes it doesn't cancel with the bottom, so you could just leave it as is. And then circle your answer. Because again, this is just simplifying. The process goes back to when we're solving. But right now, we're just trying to simplify our radicals.